So we said that any oblique line is the graph of a linear function. How can we figure out what linear function that is? Well, in order to do that, we need to think about the notion of the slope of a line. The slope of a line is a measure of what direction the line is in, and it's calculated as the change in y over the change in x. So we take 2 points on the line, we subtract the y values, we subtract the x values. And if we have a straight line, that ratio will be the same for any 2 points. The reason for that has to do with similar triangles. Using the slope, we can write a general equation that will always let us directly write down the equation of a line. If we take our definition of the slope and we multiply both sides by the change in x, we get this equation called the point-slope form of the equation of the line. And since we have the same slope for any pair of points, we can just say, okay, then any point xy that's on the line has to satisfy this equation. Remember, x1 and y1 are given values. If we want to think of this as a linear function, we need to have this equation written with y by itself. So we'll add y1 to both sides. And then we can simply write that in function notation. Now, there are a lot of different equations that we can get from the same line using this technique. But we'll find that when we simplify them, we end up seeing that they all represent the same function. Let's see an example. Here we have the graph of a function f, and we've marked 2 easy-to-read points to save hunting for them. We're asked to write 2 possible equations of f in point-slope form, and then simplify both of them and show that they actually represent the same function. So the 2 points we have marked here are -6, -4, and 4, 2. Now, there are ways we could calculate the slope directly in the picture, but I want to use the formula in this example. We'll say that our slope is the change in y, 2 minus -4, over the change in x, 4 minus -6. So I've chosen to make this point my x1, y1, and this point my x2, y2 in my slope formula. I could have done that in the other order. I could have said -4 minus 2 over -6 minus 4. And that would have given me the same slope. The first one gives me +6 over +10. The second one gives me -6 over -10. And each of those fractions simplifies to a slope of 3/5. The slope of my line is 3/5. And it doesn't matter which order I put my points in, as long as I go in the same order for my x values and for my y values. I like to go in the order from left to right, so that when I do the subtraction in my denominator, I end up with a positive number in the denominator. But whatever order you use, you'll end up with the same slope. Just make sure you don't switch. Okay, so now we want to write our function in point-slope form. And for that, we need to choose a point. We can choose either one of our points, and we'll get 2 different equations. If we use the point -6, -4, we'll get the function f of x equals 3/5 x minus -6 plus -4, or 3/5 x plus 6 minus 4. If we use the other point, 4, 2, we get f of x equals 3/5 x minus 4 plus 2. And those look different. Those look like they might be different functions. Those are definitely not the same expressions. But look what happens when we simplify them. The first expression, we have 3/5 times x plus 6 minus 4. That's 3/5 x plus 18/5, and then minus 4 is 20/5. So we'll have 3/5 x minus 2/5. Meanwhile, the second expression, we have 3/5 x minus 4 plus 2. So that's 3/5 x minus 3/5 times 4 is 12/5, plus 2 is 10/5. So that's 3/5 x minus 2/5. And again, you can use your calculator for the fraction arithmetic in that if you're not uncertain. But what we notice is that those both simplify to give us the same expression. Simplified, we have f of x equals 3/5 x minus 2/5, which is the equation of this line in the form y equals mx plus b.